بسم الله، الحمد لله، والصلاة والسلام على رسول الله. الطلبة الأعزاء، السلام عليكم ورحمة الله وبركاته، وأهلا ومرحبا بكم في هذه المحاضرة الأولى من الشابتر الأول لمادة Engineering Drawing 2 الرسم الهندسي 2 الذي بعنوان Review of Engineering Drawing Fundamentals. The topics in this lecture are object representation containing multi-view projection, glass box concept, orthographic projection of point, line, plane, surface, and object. Next, line convention. Starting by object representation, any given object can be represented by two ways: axonometric projection, this is 3D representation, and multi-view projection, this is 2D representation. For multi-view projection, three principal dimensions of an object are needed: width, depth, and height. Can be represented only by view. For this view, we can see here the width and here the height only. Adjacent views is needed to fulfill the size description. Then, to view the depth is on the side view. For the top view, we can see the same depth also. To obtain multi-view representation of an object, we have to revolve the object with respect to observer, or the observer move around the object. Here we have an object. We can revolve the object to obtain this view, for example. This is the front view. We revolve again to obtain this new view. This is the right side view. And here also, the object will be revolved, and then we obtain the top view. We have an observer now in front of the object. Here, the observer can see the front view. Now, the observer revolves from the other side. He can see this is the right side view. If he revolves from the top, now he sees the top view. The glass box concept. This is a glass box containing the three views: front view, right side view, and top view. If this glass box it is open like that, to make all views in the same plane, all views are represented in the same plane like that. Here we have all views. This is the height. It is the same. For the front view, this means elevation, right side, left side view, and rear view. Here we have the width. It will be the same for top view, front view, and bottom view. and here we have the depth. It is the same for top view, right side view, left side view. Okay. Projection of an object. The views are obtained by projecting all object features to the picture plane. Here we can see the front view or the elevation. By orthogonal projection, also we can see right side view. First, here, this line, it is the same here. And this line, it is the same here. But this line is from the front view or the elevation, and this line is from the top view. This line and this line here, it is from the front view, and this one, it is from the right side view. If we continue here by the same way, by orthogonal projection, we can find the all views for this object. One remark here, projection used or method used for projection, it is third angle projection. Third angle projection. We'll continue with dashed line. And this is the representation of this object. You have to project the remaining surface, which are invisible too. All invisible surface are represented by dashed line here and here. Another example here, the first surface, second surface. Here we get the front view. This is the depth. We start with this surface, we can obtain top view, and now right side view. Another example, surface by surface. Okay, this surface here, this surface, finish the front view, now finish the top view, and finally the right side view. Okay.